Hello, I'm Cameron from the University of West England, and I'm here to present Squishy Yet Satisfying, exploring deformable shapes, cross-modal correspondences with colours and emotions. This work was conducted at the University of Bath and is supported by the European Research Council. So when we think of the devices that we carry around today, a lot of the common screens and things in our environment, they're often these kind of lifeless kind of bricks. They have kind of no real kind of tangibility to them. You can't kind of get a real sense of kind of haptics from them, and they can't really change their shape or form. And over the last kind of few decades now, lots of people kind of in this space in the Kai community have been working on creating devices that allow you to kind of squish into screens or change shape to kind of create these different applications and different tools. And a lot of this work in this space is focused mainly on the sort of fabrication and the novel interaction opportunities. And there's been sort of limited ways in terms of kind of creating kind of design guidelines for these, so of how we might kind of use these UI in the future and how people actually perceive and interact with them. So this work sort of turns to some of the kind of psychology level that we can draw upon, and particularly cross-modal correspondence, which is the sort of non-arbitrary associations humans make between features of stimuli, both within and across sentences. For example, taste and sound, touch and visual, and this can be used to kind of create intuitive design guidelines for these new and innovative tools. And some of you might be familiar with a very common, kind of commonly cited cross-modal correspondence from years ago, in which most people would label this shape here as boba, and this more spiky shape as kiki. And this is kind of reliably demonstrated across cultures, across generations, as a real gold standard in cross-modal correspondence. And cross-modal correspondence is not new in HCI. So some people have already started to use this to kind of map out this guideline that we have for kind of tangible interactions, shape-changing interactions, and now deformable interactions. You see here on the side some boba and kiki shapes in which people were touching them and associating them with colors and emotions. In the center there, looking at how shape change, so changing from a boba and a kiki shape can kind of affect emotions and such. And then our work from last year at Kai, in which we looked at how deformability and things that kind of squishy and have different stiffnesses and how they relate to visuals such as color and different shapes. And what this is doing is, I think as a community, we are starting to kind of build and map out a real great set of guidelines. So when people come to build these tangible interfaces, we have things that are rooted in psychology. So what are we doing in this study? So we're taking this a step further now, and we're looking at how stiffness and shape together can be used to associate with color and emotions, and we did these kind of under a visual and a non-visual condition. So, and the key contributions we have in this work, so the kind of the headlines, the key takeaways, is we show how different shape features, stiffnesses, and the amount of force that the users apply interact to determine the associations between colors and emotions. And I'll be going through these sort of in our results, and also at the end kind of showing the guidelines for how to use these. We showed that kind of through our tests that the visual modality has little influence over the user's associations. So the actual visual modality that we tested kind of had little impact compared to the actual feeling and kind of tangibility that brings into it, which is really kind of interesting, kind of show how dominant these kind of more haptic sensations are. And like I said, we kind of outline all these in a guidelines, so hopefully immediately researchers and designers can put all this into practice. So our user study. So we created some shape stimuli. So we based these off kind of boba and kiki, emergible shapes. So a lot of the common kind of shape changing interface research kind of looks at this idea of pin-based arrays. So we used that as influence for our emerged shapes, again sticking to the boba and kiki versions of them. And then finally on the end we used a porous shape, and this was based off the Morphe shape that was used in our previous study where we looked at the associations of stiffnesses and shapes. from a visual perspective, and this was one that was kind of really significantly promising from that study compared to a lot of the other shapes used. So we continue to study this one in this study as well. Then the actual stiffness levels we used. So we made the shapes, kind of casted them using kind of 3D printed molds out of silicon, and we did this at a soft level, a medium level, and a hard level. And a really easy way to kind of understand this is that our soft one was softer than your fingertip, the medium one was sort of as stiff as a fingertip, and then the hard one obviously harder than the finger pad. And this was taken from the impact of softness on users' perception to cultivate for future soft curvature and shape changing interfaces, which was work presented last year at CHI. So our actual demographics from a user study, so we did this with 52 participants, so quite a large sample size. Each test took approximately 45 minutes to kind of go through the different stimuli. 4 of our participants were left-handed, and we had a 50-50 split between female and male, and our average age was 32. So what was the actual procedure? So in task 1, they would match the shape stiffness to a color, and then in task 2, they would match match a shape stiffness to the pad scale, which was a scale of pleasure, arousal, and dominance. And each of these tasks was done under a eyes free and an eyes on. We obviously counterbalanced these tasks to make sure that there was a spread across the participants. And each one of the tests concluded with a semi-structured interview where we asked about their associations strategies. What did we specifically measure? So with the color, when they were picking their color, they would pick a hue and a brightness, and these kind of color that we presented were based on previous cross-modal studies that have kind of looked at color quite significantly. For the emotion, like I mentioned, we used the PAD scale, which measures the pleasure, arousal, and dominance. We use a scale from 0 to 100, although they didn't actually see the scale. They would just use a slider between these two following terms. So for the pleasure, it would be between pleasant and unpleasant. For the arousal, between calm and excited. And then for dominance, we were looking at control and lack of control and how they associated the objects that they touched with. We also measured force throughout the tasks. So we mounted each shape on a force sensor. We used a sort of calibration technique from previous papers, and we took the force levels in all of the tasks. For the purpose of this presentation, we will just focus on the colors and emotions, but if you want to see the results from the force as well, that's also all in the paper. So our analysis, so we used a repeated measures ANOVA to investigate the effects of the stiffness, the effects of the angularity of the shape, so the actual shape property that kind of dictates how sort of spiky or curved it was, you know, the Boba and Kiki from the start of the presentation. And obviously we looked at our visibility conditions and how they affected the choices. And we did this for each of the shapes associations for the colors and the emotion, and of course the force, but more of that is in the paper. So, looking at the results, we'll start with the colors. So, first of all, looking at our curve, sinuous, and emerged shapes, the stiffness significantly affects the color associations regardless of the shape. So the stiffness kind of came out as kind of the most kind of significant in this. And what we saw was the softer versions of the shapes were usually associated with the lighter shades and hues of course, yellow, greens, and blues, as you can see in the illustration of it. With the angularity, so we saw effects on kind of like between the spiky and the rounded. We saw that the more spiky the shapes were, they were associated with sort of higher brightnesses. And it's quite interesting because this has kind of been seen in kind of other studies where they weren't using kind of stiffness, so it's kind of aligning with some of that research as well. The exception was with the porous shapes. So the porous shapes, the softer versions were associated with the darker shades, so instead of the lighter shades as we saw in the kind of other shapes, and the harder porous shapes were associated with even darker shades. So here we can kind of see in things that were dark, but of course where things were even harder, they were even darker again. So kind of like set apart from some of the other shape sets that we saw. We also saw that visibility only played a small role. Like I said at the top there, we saw that the significance of the kind of the stiffness and even the angularity was much more significant than the visibility. And in the brightness of the hard sinuous shapes, and for the hue associations for the hard and emerged shapes. Moving on to the emotions. So starting with looking at the pleasure, where we saw like the most significance was between kind of the softer shapes as dictated by the sort of the white kind of shapes on the pleasant side of the scale there, were associated with obviously higher level of pleasance, while the harder ones sort of on the unpleasant level of the scale. For the curve shapes, the bulbar angularity contributed to higher pleasantness than the kiki ones. So of course, rounder, more pleasant than kind of the spikier ones, and you can see very far apart on the scale on the side there. And then for arousal levels, so kind of looking at our vertical scale there, to kind of change your orientation. For arousal, the softer curves, emerge and porous shapes were calmer, and the harder stiffness more exciting, and the bulbar versions of curb and sinuous shapes contributed to calmness and kiki to more excitement. Finally then, again, we only observed a few effects for the visibility. So the visuo-tactile soft emerged shapes, so that's the shape that people saw that were soft and emerged, was associated with more pleasantness, and seeing the curves only influenced higher differences between soft visuo-tactile and the hard tactile only for arousal. Moving on to kind of the dominance scale then. So for both the bulbar sinuous and the curves were rated with higher level of control compared to the kiki. So the rounder ones obviously coming out at significantly higher levels of control. And then for the emerge, the stiffness played an additional role, with a higher control was associated with harder shapes than the kiki. So, design recommendations. So one of the key things we wanted to do with this work was to not only study it from a sort of, a cross-modal sense, but to actually create recommendations that researchers and designers can go and act on now, in terms of making tangible interfaces, shape-changing interfaces, and things with deformability. So our first recommendation based off our results is to use soft and round shapes when you want to kind of elicit kind of associations of pleasantness, and of course use kind of spiky shapes when you want to elicit unpleasant associations. It's quite an easy scale there. Then an easy one for like creating arousal. So using the spiky shapes was best for the excitement, while the round shapes for calmer contexts. Then for dominance, so the rounder protruding shapes were associated with high control. Spiky shapes are associated with left control. Using a softer, rounder shape can increase that level of control. So you saw that the round, you got the difference between the round and the spiky, but then if you make it softer, you kind of elicit kind of a higher level of control. Then for our hue, so looking at our cool and kind of warm kind of color spectrum here, so the soft shapes should be used in conjunction with cooler colors, while the harder shapes with warmer colors, so your reds, your oranges and such, and your cooler ones kind of go into your greens and your blues. As for the brightness, the soft, rounded, or the spiky shapes should be used in conjunction with the high brightness, so looking at kind of soft rounded things there, or kind of like spiky levels, like I said before, kind of correlating with some of the previous work where stiffness wasn't studied, while the harder rounder shapes should be used with the darker colors. And then finally, with our visibility, based on the findings, we think that you can use these across kind of eyes on and eyes free interfaces. So using the colors that we found, the shapes that we found, these associations will go across them being able to see the interface or not see the interfaces. For example, if you're using them as a controller and you need to look elsewhere, kind of the same kind of associations of emotions or colors that you're kind of showing in a different part of their environment will kind of maintain that kind of cognitive throughput, that multimodal experience throughout the interaction. So I want to thank you for listening. This has been squishy yet satisfying, exploring deformable shapes cross-modal correspondence with colors and shapes. You can contact me, cameron.steer@ue.ac.uk. If you have any questions, please feel free to email me. Thank you very much.